All right, let's talk about voltage testing. So, I've got just a basic, simple little circuit here, but I'm going to show you how we're going to hook up, theoretically, a voltmeter, and then I will give you guys a little sort of tutorial on the electro trainer and show you guys how we'll do that. Um, First, I think it's important conceptually to understand how we hook up our meter in different settings because I can't measure my meter in the same setting if I'm or use my meter to measure amps while I'm still in the voltage setting or hooking it up like a voltage test and vice versa. So it's really important to know how to hook up the meter properly. So with a voltmeter, and let's just go ahead and we'll show here. One time I will draw a good, nice meter. From here on out, it's going to be orange circles. So normally we'll have some sort of digital face, right? I've got a knob somewhere so I can put the meter on the setting I want. In the case of measuring voltage, there are going to be two settings. One is going to be voltage solid line with dot. Mine is going to be voltage DC. We talked about AC and DC in previous videos. 99% of the time when you're measuring for voltage on cars, you are going to be measuring voltage DC, unless you're checking AC ripple or something on an alternator. Very rarely, or maybe a magnetic pulse generator, you're testing and you're not using frequency. Maybe you're using AC volts, which is going to be the squiggly line. Or V with a squiggly line. So like I said, we're almost always going to choose volts DC on cars. I'm going to have two leads that go to my meter, a red lead and a black lead. So there will be two red holes on your meter. One's going to show volts and ohms. And I may actually have three here, actually, depending on the meter. One is going to be for amps, and one is going to be for a much smaller amount of amps, milliamps. And then we're going to have one hole in the meter for ground, our black lead. And instead of negative, it's actually going to say COM on it. And COM stands for common ground. So that is what we're gonna hook up to the voltage hole, and we are gonna hook up our black lead to the common ground hole. You really want to make sure that unless you are measuring amps, you keep the meter lead out of those a-holes because they will not hold up. Voltmeters have what they call high impedance, or they are what they call high impedance meters. It means that they have a really high internal resistance, generally 10 mega ohms, something really big. And so I can hook up my voltmeter almost like I can create a short circuit, and it's not going to short because the meter itself has resistance as long as the lead that you're using is in the proper V hole. If I accidentally put the red lead in one of the A or amp holes, then you are going to have a different experience because the meter in the amp setting doesn't have any resistance at all because it's measuring current, and it would affect the total circuit current or amperage if the meter had resistance. And so in order for it to be accurate, it can't have any resistance, but you need to remember that and respect that when you're hooking up the meter. Now, most of the time, any decent meter, if the meter lead is in the amp hole and you go to the voltage setting on the knob, it will usually beep at you, letting you know that you put that in the wrong hole, that you need to stop what you're doing, pay attention, and fix the issue, and not blow up the meter. Because if you think you're doing a voltage test, you're not, you're in the amp hole, then you will blow the fuse in the meter. And here's why. Because when you hook up a voltage meter, or a meter in a voltage setting, we hook it up in parallel, meaning that there are multiple routes for electricity to flow, right? So if this is our meter here, I am going to hook up both of my leads at two given points in the circuit, creating almost like its own little branch. Now, before I start hooking my meter up to my theoretical circuit up here, it's important to know that there's actually two types of voltage tests. There are available voltage tests, and then there are voltage drop tests. Now, they're essentially doing the same thing, but the results you're going to get on the meter are going to vary, and so it's important to know the difference between the two. Let's start with an available voltage. So first off, your voltmeter, it always, no matter how you hook it up, if it's in the voltage setting, it's doing one thing. It is testing the difference between the red lead and the black lead for voltage. So whatever's on one side versus the other side, whatever the difference is in number, it's going to show me the difference. So let's go ahead and hook that up here. An available voltage test is essentially testing for how much voltage is at a given point in the circuit. Well, where do you want to know, at what point do you want to know what the voltage is? Let's say we want to know how much voltage is getting to the fuse. That would be where we would hook up an available voltage for. With an available voltage test, I need to have a constant because, again, the meter reads the difference between two leads. So if I want to know how much voltage is coming in here or an accurate reading of it, my other lead needs to be at 0, right? So the difference is going to be whatever is coming in here, if that makes sense. So that's what we do. We hook up, in an available voltage test, we hook up our black lead to a chassis ground somewhere. As long as it's bare metal. Remember, this is really important because your reading is going to be skewed if you don't have a good ground, and you're going to see 0 when it's actually not 0. So I'm going to get rid of this here. My black lead goes in the black hole on the meter, and the other side goes to the common ground, chassis ground somewhere on the vehicle, engine, body, or frame. The red lead is going to go in wherever you are trying to test at. So if I want to know how much voltage is going into that fuse, I'm going to put my red lead in the proper V hole here because we're doing a voltage test. And I am going to hook that up because it's a little metal probe. I believe I showed you guys. Looks a little something like that. So you're able, and that's actually a test light. So, but it's got a little pokey probe. And we can talk later on when you get into tune-up and electrical on how you're actually going to get behind some of these to do electrical tests. Fuses are really easy, but everything else usually needs to be back probed because metal isn't just exposed, and because we don't want oxidation leading to corrosion. And so a lot of times you'll have to use T-pins and back probe the connectors and stuff. But for right now, we won't get into that. We'll just talk about voltage. If I want to know, I would put my red probe in the fuse, and I would see a reading on my meter. And as long as I had good connections, that reading would tell me exactly how much voltage is going into my fuse there. Now, if everything's working properly, we know that we should have 12 volts there, right? Remember, pay attention to the back there, 12 volts, not millivolts and kilovolts. Make sure you're getting the correct reading here. Now, what if I wanted to know the voltage coming out of the switch? I would take my lead and I would connect it coming out of the switch. If I wanted to know how much voltage was going into my bulb, then I would probe into the bulb. Or if I wanted to make sure that there was no more voltage coming out, like say for corrosion or a bad connection, I would test voltage coming out, and I should see 0, right? If everything's working properly, I should see 0 volts. If I saw any voltage, I would know that there's corrosion somewhere back here that's taking up some electricity, and so it has to save some of the voltage for that. So that is how you hook up an available voltage test. Now, hooking up the voltmeter just simply across the battery, positive to positive and negative to negative, that's simply called an open circuit voltage test, but it's essentially doing the same thing. Now, the second type of voltage test is going to be a voltage drop test. Now, voltage drop tests, we're going to hook it up the same way, use the red V hole and the black COM ground hole. We are going to hook the meter or put the meter in our DC volt setting. Now again, this meter doesn't know how you're hooking it up on the circuit. It just does what it does. It reads the difference between red and black. So with a voltage drop test, hooking it up across a component is going to tell us how much voltage is being used up across that component. And here's how we would hook that up. Let's say I want to know how much voltage this light bulb is using. I would hook up one of my leads, and if you get these backwards, it's actually not that big of a deal. It'll just give you a negative number, but the number is the same. I'm going to hook up my meter to one side of the component, and this could be a switch, this could be a fuse. I'm going to have one lead on the inlet of the component, and then the other lead on the outlet of the component. Could be a wire, could be anything. Now again, my meter is telling me the difference between red and black. So if we look at this circuit here, and I know I've got 12 volts coming out, 12 volts, I haven't used it up in my fuse, I haven't used it up in my switch, I should theoretically have 12 volts going into my bulb, right? And then since it's a simple circuit, nothing else is coming out, theoretically this bulb should use up all of that voltage and I should see 0 volts coming out the other side, right? So then what should my meter read? 12 or 0? Well, as I mentioned, it is the difference between the two. So what's the difference between 12 and 0? 12. So my meter should read 12 volts because one side has voltage and the other side does not. Now, if I was to do, say, a voltage drop test across a switch, and this is where our nice meters go out the door. Let's say I wanted to test the voltage drop across this switch. I would hook up my meter, one lead on one side and the other lead on the other side. Now, this switch is fun because it's going to vary depending on what position it's in, right? If my switch is simply closed, then it doesn't use up any voltage. Whatever voltage coming in is the same voltage coming out. There's no difference. So everything working properly, if I have 12 volts going through the system, I can still see 0 volts. And if you don't know what you're looking at, by the way, if you hook up a meter to anything, you should always know what it should read before you even hook it up. If you don't know what the meter should read, it's not going to give you the answer. You should know in your head, okay, it should be 12 volts here. You hook it up, and if it's 12 volts, cool. If it's not 12 volts, and you're like, whoa, I know I've got a problem. But if you're like, I don't know, just check it, then it doesn't matter what pops up. It could be 12, could be 6, could be 0. You don't know, and so there's no wrong answers, right? But that's not how we diagnose cars. So you need to have an idea in your head what the meter should read and then hook it up. And that either is going to confirm or deny what you think the problem might be. Now, if a switch is closed, it provides no resistance. There's no difference in voltage. I've got 12 volts coming in and 12 volts coming out. I should see 0. Some people might read that and be like, oh, there's your problem. 0 volts. I don't have any voltage here. Yeah, you do. It's how you hooked up the meter. If I was to instead do an available voltage test and I saw 0 volts right there, now we've got a problem, right? And I know that there's a break in the circuit prior to this. But if I'm doing a straight voltage drop test across a switch or a component that's not supposed to use voltage and it shows 0 volts, that's not a bad thing. Now here's the problem, and I actually prefer available voltage tests in most cases. Sometimes voltage drop tests work as well, but here's the problem. What if I had no voltage? Maybe my fuse is popped, right? But I didn't know it yet, which I'll get to that in a moment. Let's say I didn't know that there's anything wrong in my circuit. My first test is a voltage drop test, which your first test should never be a voltage drop test. Your first test should be a test across your battery and then an available voltage of what it's going in, and then you can start with the voltage drops. But right now, we didn't do any available voltage tests. We just did a voltage drop. I see 0 volts, and I'm like, well, it's a switch. It doesn't use any voltage. It's good, right? Well, the problem here is it's going to read 0 volts whether it's 12 volts and 12 volts coming in and out of the switch. But it's also going to read 0 volts if I've got 0 volts and 0 volts coming in, because there is 0 difference between 0 volts and 0 volts. So that's a problem with voltage drop tests. Like I said, you always want to confirm with an available voltage test to make sure that you're not running into a situation like that. But that's what I mean by hooking them up in parallel. See how electricity can flow through the switch or it can flow through the meter? We added a little branch there. No matter how you hook it up, if it's available or voltage drop, that is what what a parallel branch would look like. So we hook up our voltmeters in parallel. We know they're high impedance. There are 2 types of voltage tests, available voltage and voltage drop. We know that when we're testing voltage, we need to be on the voltage DC setting most of the time, and that our red lead needs to be in the voltage hole. So that's just in a nutshell voltage testing. I'm going to go ahead and throw up just a couple of quick examples here and see if you guys at home can figure out what the reading should be. I'm going to go ahead and... Okay, so real quick at home, I want you to pause your video here, and I'd like you to take a look at this circuit and tell me what you think each of those readings should be. Now, I'm going to give you a hint. This circuit's not going to work. So before we do these tests, I want you guys to figure out what they should be under normal operating conditions. And then we're going to go back and see exactly what they should be, talk about maybe what they could be, and how that would affect the circuit. So go ahead and look at that and pause the video so you can figure that out. All right, so hopefully you did that. Let's go ahead and take a look at our tests. So I did 2 available voltage tests and I did 2 voltage drop tests. Let's look at the available voltage test first. So right off the bat, our AV1 is an available voltage. So we know that because one lead is grounded, the other lead is at a given point. Going into the fuse, we know we should have 12 volts, right? What about AV2? We are doing an available voltage test to see if there's any voltage after the light bulb. We should have 0 volts. And let's go to our voltage drop tests. Voltage drop across the switch. We just kind of did this one, so we should know if the switch is closed, you will see a 0 volt drop. Right here, we got a voltage drop test across the power path wire going into the bulb. We should see, should it be using up any voltage? We should see 0 volts, right? Or very minimal, little amounts of voltage being used across that wire. Now that's what it should be. Let's go ahead and take a look at a circuit that doesn't work great. Now, I'm going to just sort of, you know what, we'll get rid of that. Make it easy and just do new circles. Let's look at the light bulb doesn't work. Customer came in and complained. Let's say this is, we'll just say it's a dome light or something like that, right? Customer says light doesn't work. And so we perform the following tests. First off, I'd like to make a disclaimer, or not a disclaimer, but more of a tip, sorry. If you were doing any electrical testing on the vehicle, before you do anything, test the battery. Because if your battery is dead, then nothing else can work, and it's going to save you a lot of time and hassle. Also, if the voltage is just low, everything else in the circuit, what if you don't test your battery and you test that there is 6 volts going into the light bulb? Well, then you're going to be like, oh man, there's resistance in the circuit. Something's bad, right? What if there was only 6 volts coming out of the battery? Who looks silly now? So make sure you always test the battery first. Now, I am of the mindset, work smarter, not harder. And so one of my first go-tos after the battery is usually the fuse, because it's easy to get to. Always start with the easy stuff. Think of A, what's easiest to get to, and B, what's most likely. Fuses pop a lot due to a number of reasons. So before I test any other part of the circuit, I'm going to make sure that the fuse is good. If the fuse is not good, I'll replace it. And if it doesn't pop, I'll test throughout the circuit to see if I can find the problem. But those are just a couple of things I definitely would recommend doing. So what we're doing here is we're testing for voltage going into the fuse. And I'm going to tell you this light bulb doesn't work, and I'm going to give you these readings, and then we'll figure out why. So first off, right off the bat, if we were in class, I'd give you these readings, and I would make you guys tell me which readings give you the indication that something's wrong. So if you're looking at those at home, you can pause the video if you need. Let's figure out which one of these does not belong, which one doesn't look good. Now, we know we should have 12 volts coming in and 0 volts coming out. So that looks fine, but again, the light doesn't work, so there's something wrong. We know that this wire does not drop, shouldn't drop any voltage, so that number doesn't bother me too much. What about this one right here? Some people might see that and be like, hell yeah, there's 12 volts, but we just talked about this. Problem is this voltage drop test tells me the difference between here and here. And what 12 volt reading tells me right here is that I have 12 volts going in, but 0 volts coming out. So right here, looking at these readings, the bulb doesn't work because we have a faulty switch. Either there's an open inside the switch, or the switch itself is broken mechanically, but for whatever reason, that's the source of our problem right now. So that's just a couple of things to look at. And if you have any questions at all, let me know. Now I am going to show you guys on the electro trainers what that looks like. All right, let's go ahead and take a look at this circuit and how we're going to do our voltage testing on it. So I just talked about how you would hook up a meter for available voltage versus a meter for voltage drop. We know that, let's just get back to our meter quick review here. Our setting needs to be on voltage DC, so we'll go ahead and do that. And we are going to go ahead and make sure that our leads are in the correct place. So this one has 3, as I've shown in the previous videos. We've got a volts ohms terminal, and then we've got an amps terminal, and then we've got a COM terminal. So I've got the black one in COM, and I've got my red in the voltage terminal. And now we'll go ahead and set that back down. Now, for an available voltage test, I'm going to go ahead and put our meter down here so we get a little less glare there. An available voltage test, we know that our negative lead is going to stay on ground because that's our constant 0. And again, we always check our power source. Let's go ahead and do that. We've got 12.86 volts exactly. So we know that that is what our source voltage is. Now, an available voltage test, we can check at any point we want to. So if we want to know how much is coming, we just test power source going into the fuse. We see 12.86. What about coming out of the fuse into the switch? 12.64. Check that out. We have actually lost 0.2 volts through our fused link here. Now, that would be a little troubling I would want to go ahead and take a look at that, but I do know that this connection is not the best, and so I think we're losing some through that. So that would be an available voltage test. We know that 12.8685 coming out and 12.68, that's going to show a voltage drop. Well, we can hook up our meter that way to test that, can't we? I am going to, again, it's telling the difference between these two leads. So if I hook up my meter like this, it's telling me how much voltage that fuse is dropping. And we're seeing 0.157 volt dropping across that fuse. So that's fun. Let's go ahead and go back to where we were. How about going, we know 12.6968 coming out of the switch, or going into the switch. What about coming out? Same, so our switch is not using up anything. What if we close that switch? So we got 12.8 coming in and nothing coming out. So there's our controlled open. Going into the light bulb, we got 12.75. Well, that's interesting. We somehow managed to gain some voltage there. Unless it just sort of charged back up on us. It looks like we might have got an increase, or maybe we fixed a connection. I wiggled something and we must have fixed the connection there. Now we can guess how much voltage is going to drop across each one, but we do know already that our brighter bulb, because this is a series circuit, is going to use up more voltage. So it's definitely not going to be even numbers. So we've got 12.75 coming in and 8.45 coming out. So we're looking at roughly 4 volts and change. 8.45 going into the second bulb and nothing coming out. So this one is dropping a different amount of voltage. Let's do a voltage drop test to show us that. So we know this one's dropping around 4 volts. Well, exactly how much is it dropping? 4.3 exactly. This one we know is around 8-ish volts and change, almost 9, 8.5. And we can see there's our voltage drop right there. So that's how we would do an available voltage and a voltage drop test. Now, obviously on a car, things are a little bit different. Notice I sort of stuck the probes behind my connectors here. This is meant for that. Your cars don't have that. So you're going to need to be gentle. Don't just start taking probes and jamming things in, because you're gonna mess stuff up, especially computer controlled type stuff. So be very careful. Use T-pins. But that's how you complete a voltage test using a digital volt ohm meter.